Hello, good morning, evening or afternoon, wherever you might find yourself in the world. I hope everyone's having a pleasant Sunday. Here we are, the next phase of the game development. We've had enough of resource packing for now. Move on to something a bit more visual, a bit more fun. Kind of, yeah, physics. It's going to be definitely a multi-stream one, this, I suspect. Hello, Queco. Daggers, Julian. Glad you're here. So, yeah, got up in the corner here. The fruits of our labour so far. It's time to start getting some of these barrels moving. Hang on, let me just. That's better. Okay, so what are we going to do? What's the plan? I think physics is kind of the last big feature before we can. Well, before we can start making a game, it's the last excuse for putting off making a game, right? To actually have some sort of interaction and trying to find some sort of fun in this. So, yeah, so we're going to start. I suspect physics will be a multi-stream endeavor. There's going to be some issues, I imagine. It's probably not going to work the first time, and then we're going to need to put in some sort of visual representation of it so we can debug it. And yeah, we'll kind of get on with that. I've inspired you to learn some C++20 and do some game programming. Glad you're enjoying it. Well, I hope you haven't said whether you're enjoying it or not. I've inferred. I'm trying to infer, sorry. I mean, that you are enjoying it. C++20 is great. Good evolution of the language. Some good stuff in there. We're using as much of it as we can. Well, and the 23 stuff. Have I decided which lib we are for physicking? I think I have. Kind of a late breaking decision. I kind of decided pretty last moment what it's going to be. I think we're going to use the grand reveal. I think we're going to go for Jolt. Multi-core, friendly, rigid body physics and collision detection, suitable for games. Big tick. Used by Horizon Forbidden West. I believe it's the physics engine in Godot, or at least one of the options. Yeah, I think so. I'll tell you why I landed on this. Okay, because I've always used Bullet, right, and I kind of know it, like at least a little bit. I have some familiarity with it, but it's been a while since it's had like a release. And yeah, okay, there are like still commits going on, but I feel like it's quite an old graphics API. And I'm not saying that's bad. It's pretty battle tested. A lot of places have used it, so there's nothing wrong with Bullet. Jolt feels a little bit more new, a little more modern, a little more up to date. It's had a commit 25 minutes ago. It had a release in November. It feels pretty. It's got 0 bugs, so can't argue with that. Whatever that means. It's CMake, which is a big deal for me. I had a little look around here earlier. It's got a build directory. It's CMake, so that means it's easy to integrate. And also, let's see where else. Like features, it's got all the shapes that I would possibly want. It's got a load of other stuff we won't need, but it's nice to know it's there. Kind of means it's fully featured. Supports all the platforms. Uses C++ 17. Doesn't use exceptions, but nobody is perfect. And then, yeah, I think as well for me, I get there's a fair amount of feedback I get from these streams that people kind of like seeing me solve problems and how I approach things. And I think using something I've never done before is, I think, hopefully interesting for people, because like there's a lot of questions I have around this, like how exactly does it integrate into CMake? What is the API like? How do I consume it? How does it fit into my existing code? How am I going to wrap it and abstract around it? Do you know what I mean? There's kind of a lot of I've literally never used this before, so this will be me kind of figuring it out live. Whereas with Bullet, I've got example code that I can draw upon. I can kind of got past experience, so it might be a slightly smoother process. But I thought this might be a little bit more fun to, I don't know, kind of have a go at doing something new, because I'm sure between all of us we can sit down and figure this out. So there, right, well, I think we'll give it a go, basically. So yeah, so I think the plan is we're going to probably, for simplicity's sake, strip down to, well, I'm going to try and get it into the build system, get it building, at least get access to the headers, so we kind of convince ourselves that it's all integrated. Then we're going to strip our scene down to probably just one barrel, and then we're going to create a physics, whatever the physics things we need to create in Jolt. I suspect there's some sort of like world or simulation object, create some rigid bodies, and then have like a step or update function, and then we'll basically get those rigid bodies. We'll have a static, probably like a plane, and then a dynamic cube or something to start with. Get that falling through, wire it up so that the position of the barrels follows that, so we can basically drop it and see it hitting the floor or whatever the shapes is. There's a barrel, I think it's a cylinder. We're just going to iterate on it until we can basically get a barrel rolling around, and then if we can kind of create a character controller, and then we'll need to create a character controller so we can push it around. That's kind of where we're at, and we'll need to do some debug drawing as well as on the line. I assume there's some way of doing debug rendering with it. I imagine if it's anything like Bullet, it'll just like vomit you a bunch of lines and you have to figure out how to draw it, but that's kind of where I'm going with that. So yeah, I think we'll kind of get started. So probably CMake's a good place to start. So I'm going to hope I can fetch. So this is already interesting because normally I would fetch content, use fetch content declare, but this doesn't have a root CMake file. I believe it's all in build, so you have to figure that out. I'm assuming it's not going to be too much of an issue. But yeah, there's like a build type. It's README. Includes, defines. So this is like, I like it that they have properly like project namespace CMake variables, and two, that it kind of documents them. I don't have to go through them all. So this is, I don't think I care a lot about this, but I definitely don't want it to be a shared library. I've no idea if this is the default or not. We can have a look at the artifacts, building, Windows, CCL. Interesting. It's got a bat file. So what does that do? Oh, it literally. Okay, fine. Ours will do that for us. So that's fine. Okay, let's see if we can bring this in. I'm just going to bring in the root project first. Right. I suspect this won't work, but and then how are they doing their sorry, this is what I normally do. I'll get the URL, put it in, and then I look and see how they tag in it. Pretty standard semver, so that's fine. So I'll take I prefer to pin against the specific version. Just means if stuff changes under our feet, we don't have to worry about it. Right. Where's my code gone? Right. Version 5.2.0, and then Jolt. PhysX seems to have ended support in 2019. Yeah, so the thing with PhysX is, doesn't it have like kind of a weird dual license as well? So I guess that's another point as well, is Jolt is the MIT license, so don't have to worry too much about that. So yeah, we're using CMake. Why not roll my own physics? So I have attempted to write, I have written my own physics engine before, or started to, and it's just I had like a simulator working, so it would do the integration and do the like velocity calculation and stuff like that. And then I did have collision detection and resolution for boxes, and it was such a huge amount of code and debugging just to get that. And I was like, cool, this is good. But if I want to actually use this, I then also have to have like a capsule shape, and I also have to have, like height map or terrain or arbitrary mesh, then I'd have to, and then you got all the optimizations as well, like broad phase and narrow phase. And I was like, it's just too much code to write. So whilst this is notionally a game project from scratch, the two concessions I said I would make are parsing file formats. Like, I'm not going to write a ping parser. That doesn't seem like a good use of our time. And physics, just because of the complexity of it, I would probably opt to use something off the shelf. So we'll see. Apparently my Twitch stream is unstable with a very poor bitrate. Anyone on Twitch can confirm? Seems fine. Okay, well, I'd be very surprised because I finally wired up my office with Ethernet to the internet hole under our stairs. So I'm getting like a gigabit to my PC now. So I'd be very surprised if it was bad and like 100 meg up. Yeah. Who knows? My shoddy wiring. I'm not really a hardware person. Might be my undoing. I mean, C++, so the question is, what do I think if C++ gets something similar to Cargo, assuming like a package manager? There is Conan already. I've not really any experience with it, but I've heard good things. So I don't know. I think C++ could do with a more standardized package manager. I guess there's also VC package as well. I'm not really fussed. That's just sort of like a tool. Cool. Okay. Thanks for all the stats. So let's reconfigure it. Hopefully this will bring in the project. So we should be able to see in depths now. There is Jolt, and then Jolt build. I wouldn't have built it yet. Source. Okay, so it's got some source. I don't remember seeing it build. What have I done wrong? I would expect that to have built it, right? I thought make available does build it. Let's try. I guess we could try linking against it. I'm not a CMake expert. I say this a lot because it is true. So GameLib. I'm going to assume it's called Jolt. Oh no, it will be called Jolt because that's what I've called it. No, I bet the problem is it doesn't know where the CMake file is. I don't know because it's in that build directory, right? Because what CMake make content available does is it searches for a root CMake file, but that is in build. So I need to go and have a look at the docs for that. Fetch content declare. Hey, see, glad you're here. Isn't it? Lots of questions. So the tag question was, it is definitely 5.2.0. I believe it would fail if it didn't find a matching tag. What I want to do is, where do I tell where the root CMake file is? Function records the options that describe how to populate this precise. So we've got the source. Let's try to qualify. So we don't care about find package because we're not using find package. Fetch. Is it source subdir? Okay, fine. I did see that. I wasn't sure. So that would be. So we're saying source subdir. And then. Yes, but sorry, sorry, I was just reading the comments. The question, so yes, when you say you want when we want this directory here, is that relative to what? So is that just build, right? Is that relative to the code that checks out? Sorry, I had I completely lost my train of thought for a second there. Do we think it's relative to the checked out code? The git root. Well, you know what? We can but try. Fortune favors the brave. Oh, that is a lot more files. I strongly suspect this has picked it up. I think I've. Okay. Cannot open file. Jolt.lib. This is in the unit. I want to statically link it. I want to. So. What's wrong? Cannot open file jolt.lib. Plus steps jolt build. There we go. Okay. I feel like it's not built it. So in the root lib, I thought I'd done this here, right? Because I was like, target link libraries, Jolt. Because we did that with the imgui lib and async, right? And those are all CMake projects. And something CMake, it should resolve this. It should resolve this to this. I've got the sub build. But it's not producing any artifacts. I don't think we've got any artifacts here. So I felt like, well, it definitely. Interesting. It's built the game. It's like there's 145 files to build. It's then built the game and gone, I can't link against it, which makes sense because it's probably not finished building the library yet. So why is that? But why is that a dependency issue? Because this is a public dependency on the lib, and the game uses that. So that kind of breaks my understanding a little bit of CMake, because the whole point is let's just blow the build directory away and we'll start again. Have I tried J? No, I've not. I have no opinion on it because I've not tried it yet, and I know absolutely nothing about it other than like who's developing it. How long did it take me to get familiar with NeoVim and Tmux to be able to work much faster than you could with an IDE? I think it's a good question. I kind of convinced myself to use Vim when I was at university. I was like, nope, I'm going to learn it. So I did all my coursework in Vim, and that was slow and it was painful, and it took me a lot longer to do those courseworks than it would have. But kind of spending forced myself to do it over a couple of years. When I graduated and got a job, I was like, I can now only use Vim. So I can't really put a time frame on it, but I've been using Vim now for well over a decade, and I'm still not very good at it. Right, CMake build. Okay, so it's going to build async first. That's fine because that's a dependency. I'm not huge in the keyboard niche. I've got I can't remember all the wires of the keyboard. I've got a Razer. I don't know if it's going to stretch up. Huntsman Mini, which I really like with the clicky clackety purple switches. And then I had a Corsair Cherry Reds before that. So I've not sort of gone through the whole hog and built my own and done all that jazz yet. Yeah, I find it very hard to now go to anything where it doesn't have Vim bindings. Like if I write a document, I sort of habitually write :W when I want to save it. Right, what is going on? This is not getting us anywhere, and I'm getting a little bit grumpy with it now. It's not building it. I'm pretty convinced now. It's built it's the same issue. It knows there's more files to build potentially, although this is strange because it's gone. I suppose it is. It's because it's parallelized. That's why it knows there's more things to build after this, right? And then it's like, oh, I now need to link the game, but it can't link the game because it's not built the file dependency. So I don't understand why. Of course, gotta have the pink keys. What did it say was not found? I don't think the. Well, I'm very keen to sort of not make sort of sweeping statements of like it's not this, because it could literally be anything because computers are hard. If you're new to these streams, thank you for coming along. Today is apparently going to be a CMake stream, and I do apologise if that's not what you expected, but it's a pain that we all must pay, a price that we all must pay, and a suffering we must all go through. So at least we can do it all. At least we can do it all together. Can I open file? Oh, interesting. Here, look, what's this? Oh, is it? It's not something stupid like that, is it? Because look, it's like I'm linking this static library joltlib. Beefy Beard subbing on Twitch, thank you very much. Okay. Oh, I hate all this gubbins here. It's such a pain. Yeah, so the issue was on Windows file system is case insensitive, so it doesn't matter if you call it jolt.lib or jolt.lib with an uppercase, whereas because I'm running this via WSL, via Linux, although I'm cross-compiling for Windows, blah, 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 it does care. So that's fine, I mean, I guess. This is a pain, so this is basically it's configuring it with a specific runtime library. Okay, so the MSVC RT, the Microsoft runtime, C runtime library, which has all the the stuff you need to run stuff in C, basically, like the C library, has a couple of variants in Windows land. It has dynamic, which means it's a DLL, and when you run the program, it goes and finds whatever one on disk and loads it. And then you've got the static one, which means it bundles all that stuff with you. I prefer to do static anyway because it kind of less dependency hell. But you have to be consistent across all the code you're building and all the libraries. For instance, some of your code, it'd be an absolute mess if some of your code reached out to like a dynamic runtime library, and then some of your other code was using a static one because the global variables that they had wouldn't match, for example, and like stuff like that. So this is saying that at least Windows does tell you mismatch detected for runtime library doesn't match dynamic debug in main CP. So I'm going to guess doesn't match MD dynamic debug in main CP. So I think I need to change my library to be the static one. Because these are just linker errors, right? So I'm assuming most of these don't tend to have cascading errors with linker errors. Yeah, it's exactly the same thing right at the top. So someone was saying check the first error, don't just read the last one, because you get this concept of cascading errors where you get the actual first error, and because the compiler really wants to try and give you as much information as possible, it will actually often try and compile a little bit more past your error, but then because of your error, it almost certainly won't work, and then it'll give you like effectively follow-on errors. It's like cascading errors. You don't tend to get that as much with linker errors, but it's a good point. Like, you know, it's a good trip. So I don't want it as a shared library. I want it as a static library. I want to bundle all my resources in. I want to ship a single executable with everything in it. That's the goal. So, well, you see, here's the thing, right? Joltlib mismatch detected for runtime library value static doesn't match value. So I read this as it's using this value, and it's using this value which doesn't match the dynamic one in main CPP. That's how I interpret that. So I think I need to change my code to use this because I think this is the default in MSVC. But there's an easy way to test this, right? I've got some code with this in somewhere already. I'm sure of it. I'm sure I've had to do this before. Won't the defaults be in the docs? I guess we can have a quick look. So build shared is off. When turn this option on, Jolt will compile as a shared library. So good point, and yes, it is by default off. So I think my code is using the shared runtime libraries. Not the where have I done this? I've 100% solved this issue before. I literally have the code somewhere. Test samples. Okay, I think this is it. I think what I want to do is do set target properties gamelib properties MSVC runtime library I think MTD is multi-threaded debug. Multi-threaded. We'll have to change all this when we come to do a release build, but like one problem at a time. But I don't want to compile it as dynamic. Debuff. I want everything statically built, because again, the idea is that we take, but it's multi-threaded debug static. Oh, I made a right pig zero of this, haven't I? Because ideally, in my mind, like installing and bloody, like, you know, dependencies and packaging and all that is just an absolute nightmare. I want to ship as close as possible a single DLL which has everything in it. I'm not convinced that rebuilt everything. But I could be wrong. Like, this is the worst part of C++. Like, the compiler errors and the template horrors and all that sort of stuff is by and large kind of just the price you pay for entrance. I think it's getting code written by loads of different people to kind of all coalesce in a build system that everyone uses, but everyone also kind of hates. But it's actually, CMake is pretty much better than a lot of alternatives. To be honest, I've not used that many others, so I'm a little bit opinionated in that fact, but that's kind of where we're at. It's looking good, but it'll be the link. Oh, mother flipper. Let's just... There should be no version mismatch because I'm static. I want to statically build it in. I want to include everything in the binary. So I don't understand. Let's have a look through the Jolt codes. Do they set this property anywhere? Do they set the MSVC runtime library? Yeah, but other compilers have their own quirks. So, what's this? What is? I think it's actually okay. Okay, hold on 1 moment, cooler. Right. Can I get rid of this? Ability to toggle between the static and DLL versions. The MSVC runtime Windows Store supports the DLL version. Don't care. Use static MSVC. Use a static on MSVC, not Windows off. So I need to. Maybe it is their code that's wrong. So let's do set MSVC runtime on cache ball. All the CMake runes that you need to draw in the sand to get it to do something. I don't. So someone's saying that the error comes from the mismatch in the C runtime library being different between all static libraries. I'm not convinced that's true, and I'm not saying it isn't. But one, I assumed that they would all sort. If I'm building it all from source, they would all source the same static library to include it. I could be wrong, but I don't see anywhere in the code to say please use this specific version. It should be. It would use whatever version is part of the MSVC toolchain you're using. And two, it says here it doesn't match the dynamic debug. So somewhere someone is using this and they shouldn't be. Yeah, let's just blow everything away, and start again. You might be right, but I'm not convinced. Yeah, I think. Well, this is so switching between MDD and MTD. This is what we're doing here. This is how you do it via CMake. CMake will then issue the correct, well, what you hope is the correct /MTD flag. Sure, I've built Assimp a lot this evening. That's really what I was thinking earlier about what I want to achieve in the stream. It was to build Assimp at least 3 times. Oh, is the point that it might be using a debug and a release version? It should be using, here you go, if the C is MSVC, set me, so I'm just trying to think, it should pick up the fact that what's this, set runtime library. If the config debug, pick debug, right? Multi-threaded debug, is that not? I mean, what I'm going to do is I'm just going to copy this line so it's at least consistent with what they're doing. I will set target properties game loop. Oh, also, this isn't inherited. So actually, where's this? It's in the resource packer. Have I solved this for our game? And the unit test, yeah, okay, fine. I think I've actually solved the problem. I just don't think I've solved it in all the right places. If that if that makes any sense. In fact, let's go main. Sorry, let's go CMake tools. I guess we could actually just set this as a global, like they do. Just, I don't really like setting globals in CMake, but this might actually be one of those times where we do want to do it. So actually, in fact, let's just copy that. How did you get into coding games engines for games? I'm trying to get into it, but don't really know where or how to start. So I started, I think just as I finished university, I was like, I had a little gap between before I started my first job, and I was like, I kind of want to learn some C++ because I knew I was going into a C++ role, and I was like, just try making games. I've always kind of like on the side been playing around with games. I played around with like C# X and A. I played around with some M-script and stuff, some 3JS stuff, and I always like the idea of just building stuff. I've always enjoyed building engines more than games. Like I like the idea of like solving all like the low-level problems and building out APIs and kind of, you know, creating all the building blocks. Actually building a game is probably harder and... Oh, we've linked. Exciting. So yeah, I guess I've kind of just always played around with it. I think if you want somewhere to start, it's kind of hard to know where to start, because you kind of got to decide whether you want to build an engine or a game. But having built an engine, I attempted to build an engine before, I think unless you're building a game alongside it, it's very hard to know what to focus on and where, like, you know, whether it's going to be any good because you don't actually have anything driving it. So I would definitely just start building small games. If you want to do C++, then it's like Raylib or SFML or SDL or something like that, which kind of gives you a lot of the primitives. Just get blocks moving around and then be like, okay, I've built like a clone of Flappy Birds or something. How do I do that with just OpenGL or DirectX? And you can kind of build out a path from there, I guess. Yeah, I agree. There's keep the task. If you want to learn something and actually finish something, keep the task small. I spent 2 or 3 years as a side project working on my game engine, and I've just had to stop because I've architected myself into a corner. It's just so impossible to make any progress, and it's actually very difficult to make a game in it. So whilst it's not wasted effort because I learnt a lot, the actual output isn't actually that great. So kind of really depends what you want to. If you just want to write a load of code and learn something, then try and make an engine. Do you know what I mean? But if you want to produce something like a game, then maybe don't start there, or start there in the very simplest case. It's kind of like what we're doing. We are kind of building an engine here because we're doing the windowing code, and we've done the graphics code, and we're going to build, we're going to bring in a physics engine, but we're going to wrap that in our own primitives. So, but this is all. I'm only writing code that takes us towards making a game, and that's kind of what I'm trying to keep in mind, and not get too waylaid with side quests. Whether you think the resource packing was the side quest or not is kind of is up to you. Yes, I switched to. I'm trying out the fish terminal, which is why it looks slightly different. I'm kind of enjoying it, or the fish shell, I should say. Okay, right. I don't really know what to do now. I feel like spent nearly an hour doing that. Okay, let's go to. I believe it said they had some. I'm sure I saw somewhere there's like a Hello World example. So, wait, how does this work? Yeah, do I have to Sure, I don't have to define my own broad phase. I was kind of hoping just out of the box they would do that. So in physics engines, I'm not an expert in this, but there's basically 2 phases. There's the broad phase where every object has like a cheap-ish to compute bounding box, normally a cube or something like that, and then it will do that first to basically cull out anything that it knows cannot be intersecting, and then once it's got a list of broad phase collision pairs, things that might intersect and need resolution because they're sort of cheaper proxy objects overlap, then it'll do the narrow phase where it'll actually go through and do the more complicated one, which might be even down to like per triangles. Interesting, it's got a contact listener, so that's interesting. So this will be some sort of callback. So when there is a contact in the physics engine, as in like 2 things are touching, this will get called. And same for the activation. So I'm going to assume this means like sleeping. So the physics engine can put things to sleep for a while, so it doesn't have to keep checking them up until maybe like it's picked up in the broad phase. Well, I was expecting just like a physics system. So what have we got here? Oh, at least there's lots of comments. I do appreciate that. I guess actually in Bullet, do you define a broad phase in Bullet? You might do. There's quite a lot of setup stuff for Bullet, so maybe this is it. So you create the physics system, and then I'll go into this later. I hate 2-phase construction, but we give it all these things, and then we set the activation listener, which I'm hoping we can just ignore for now because I don't care. I just want to get things going. But the main way to interact with the bodies in the physics system is through the body interface. There's a locking and non-locking variant of this. We're going to use the locking version, even though we're not planning to access bodies from multiple threads. Interesting. Ooh, we'll probably just follow their guidance. Here we go. Rigid body serves the floor. Make a large box. Interesting. I saw it did have a plane, but I guess we use theirs. Note that for simple shapes like boxes, you can also directly create a box shape. Should be marked as such to prevent it from being freed when its reference count goes to 0. Sure. Create a shape. So this is the floor shape. Create the settings. Create the actual rigid body so you get back a pointer. So we'll wrap all this in our own like rigid body class. Add it to the world. Now to create a dynamo to bounce on the floor. No, this is the shorthand version of creating any bodies as well. Blah, 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 blah. Set some velocities, set a delta time. We'll probably just hard code to that because I've got vsync anyway, so it's locked to my monitor refresh rate. Ideally, you would separate out you'd have an update loop such that the physics always ran at a fixed rate, and then the graphics would just render as fast as possible. But we can kind of get into that later. Fish is pretty good. I like it because it's got a GUI configuration. You literally type like fish config and it'll open up a browser. I can't remember what it is actually. Actually, no, I don't want to open up some other browser I've got stuff monitoring on. And then I stick it all in my dot files so I can kind of get it anywhere. Okay, here we go. Now we're ready to simulate the body. Definitely don't want an unoptimized broad phase. Definitely want to optimize it. Let's just start writing some code and see what happens. Basically, I'm going to follow this, and we're going to see what happens. What are they called? Are they called theirs system? We'll go for physics system.h. Once. Space game. Class physics system, and then we'll have some public and some private in there. And then let's, whilst we're here, do check we can do the includes. Yes, source. So this is the CPP. Hash include physics system name space game, and then physics system. Okay, let's just get this wired up into CMake so we know we're building it. And then P. No, that's not what I wanted. Still not what I wanted. Yeah. Okay. Okay, right, so now let's... So we want it seems to be the first object we want to make is the... ultimately, we want to make the physics system objects. What header file's that in? Probably Jolt physics system. So let's see if this all works. If CMake has done its job, then I should be able to just, yeah, that. Jolt physics system. And then, oh, is it not namespaced? Oh, this is interesting. So it's always worth reading the docs here. The Jolt headers don't include Jolt.h. Always include Jolt.h before including any other Jolt headers. I'll have one of those. And then I can't believe it's not namespace. That's crazy. Thanks for including that again. Oh no, it is namespaced. Sorry. Okay, so let's check that. This is kind of like the last acid test. As in, can we include headers? Can we create an object? Can we link against it? Okay, fine. So now we have basically all the machinery set up now. So what I should be able to do then is basically say physics system, and then I should be able to jump to the code and have a look at what. So it has a default constructor, which, oh, of course, does it use this in it? Okay, right. So I'm gonna talk a little bit about C++ design and class design and my opinions on it, which, I mean, feel free to make up your own decision, but here's my thoughts on it. I don't like having usual short and coming. Okay, let me start again. I don't like having an init function like this. This is called two-phase construction because you construct the object in one phase and then you initialize it in the other. The reason you would normally do that is because you cannot communicate an error from a constructor without throwing an exception. And if you don't want to throw an exception, you would then use an init method and return like a ball or something. This doesn't even do that. So it's interesting. This is literally just like construct the object and then initialize it. Now, obviously, my thoughts on exceptions notwithstanding, like they are good, but regardless of that, the problem you have now, I find this confusing in several, like, this is confusing in two parts. One is confusing for the user of the class because as a consumer, I always have to remember to call init, okay, with the right arguments, but then also like if it fails, like what state does that leave this object in? But also, what happens if I forget to call init? What happens if I call init more than once? What happens if I copy it? Like there's a whole load of like mental overhead now on this two-phase construction. Whereas if the constructor either constructed or it didn't, then all these problems go away. So that's kind of one issue with it. The other issue is on the development side. If I am requiring someone to call initialize to me, what do I do in all these other functions? Like, is that now a precondition of all these functions? Do all these functions now have to have code in which checks if it's been initialized? And what does it do if it's not? Do you know what I mean? Like, it adds a whole load of unnecessary complexity when literally the point of the constructor is to construct the object. Anyway, I'm kind of going off on a bit of a tangent here, but I feel quite strongly about two-phase construction. I'm sure there are situations where it is needed. I am not convinced this is one of them, but also, again, I've not written a physics engine that's been used in a AAA game, so like there's also that. But in terms of just general design, like I'm not crapping on Jolt here. I see this and then I feel like I should share my opinion on it. As long as it doesn't have two-phase destruction, because that is even gnarlier when you have to remember to call like a undo, like a delete or destruct function, and then the destructor. There is no three-phase construction. We don't. We don't do that. You do it because you don't want to hold a pointer in every object and don't like having to have stuff static. I'm not really sure I understand how that is related to construction. This object is correct. I mean, mine's gonna be stack allocated, right? It doesn't have a destroy. Does it have it? Sometimes it's called like dinit. No, okay, fine. I think we're okay. Anyway, this in my mind it should be a constructor, but at least, but you know what? It's really, really well commented, and I fully appreciate that. So normally I'm an absolute stickler for comments. Like I'm an over commenter, like more comments than code, and I will not normally commit anything without comments. And I've not commented any of this code just because we've been doing it live. So I will need to tie that up at some point. If the object depends on some context to create destroy, you need to pass the context. But why would you not just pass that into the constructor? But anyway, again, slightly off topic. Well, no, not off topic, but it's not moving as close to where we want to be. But that's my thoughts. You are obviously feel free to form your own opinions around these kind of things. been bitten by two-phase construction before, and it's a massive. I mean, both used it and written code that had to use it. I've yet to see the advantage of it. Okay, so this wants a in-max bodies, so the maximum number of body support. So they've gone for. So let's go for. Const expra. They've gone for stood unit 32T G max bodies equals 124. That's not what I wanted. Sort out my headers because that's already annoying me. But okay. So oh no, wait a minute. No, I'm trying to call it like a constructor, aren't I? I've just spoken at length about how it's going to work, and then ignored it. Okay. So now we can do physics system dot init. Interesting, uses the MSVC C# naming convention of upper camel case for functions as well, which is interesting. Okay, so we've got the maximum bodies. What else do we need? We need the num body mutexes. So number of body mutexes used should be a power of 2 in the range of 165. Use 0 to auto detect. They've gone for 0, so we'll do auto const expra auto num body mutexes equals 0u. So this is basically what I'm going to do now. I'm just going to sort of build this up bit by bit until we get somewhere with it. Yes, Pascal case, you are correct. For some reason I call it upper camel case, but I think I might be wrong on that one. In max body pairs, so in max body pairs, maximum amount of body pairs to process, anything else will fall through the world. So this number should generally be much higher than the maximum amount of contact points. So this would be, yeah, this presumably in the broad phrase, this would be like, here are pairs of objects that are intersecting. So they've gone for 1024. Max body pairs 1024u, and then I think the next one's in it as well. Max contact constraints. I'm going to assume that's max number of contact constraints to process. Anything else will fall through the world. Oh, have I misread that comment? There'll be lots of bodies. Yeah, okay, fine. So I think they've done the same. Max contact constraints. Max body pairs, max max contact constraints. Okay, we're getting somewhere, I think. Oh, super chat from Anoni. Thank you very much. Started with OGL and C++ at the same time on a project and was way over my head for a while, just getting my bearings. Glad to see more resources being made for this. Also love the reverse engineering videos. Yeah, so I mean, there's just, I must admit, like ChatGPT, is pretty good for OpenGL code, like to get you started, because there is a lot of OpenGL code out there. Some of it's a bit old, and maybe not like the latest and greatest like DSA stuff. But I like ChatGPT is actually pretty good for getting started. Like, can you write me a shader that does this, or can you give me an example C++ code that creates a texture or creates a skybox? It's pretty good. I'm glad you're making progress, and I hope this is helpful in some way. My plan is to release some of this code in some form at some point, but I can't really give any more details than that at the moment because I don't know them. But it'd be nice to kind of get some of this out there. But thank you very much for the super chat. Very kind of you. Yes, Haran, glad you're here. Yes, I've been moaning about two-phase construction, about having a constructor that takes nothing and then an init which takes everything, especially when the init is a void. So there's literally no reason to. But apart from that, yeah, we've just started figuring out how to Jolt. What is Jolt? It is an open source physics engine. We're going to make a wrapper for it. We're going to see how we get on. So far, we're reading docs and figuring stuff out. So now we need a broad phase layer interface. So information on the mapping of object layers to broad phase layers. Since this is a virtual interface, the instance needs to stay alive during the lifetime of the physics system. Good point. I'm glad it mentions that. So we'll probably make this a member variable so we know it definitely lives as long. So they have in their example code a broad phase, a BP layer interface impl. As this is an interface, it needs to stay alive. Also have a look at the broad phase for a simpler interface. If you don't, like, is that used? Now you see, again, this is obviously a very complex bit of code, and I'm sure a lot of thought has gone into it. But like, if this is going to own this, then why was this just not a unique pointer that was passed in, and then this just took ownership of it? I don't know. Again, I'm not here to like crap on other people's code, which is much more complex than mine, but I'm just pointing out things as I see them that I think make interesting design questions. So I want one of these. Which comes from, seems to already be included. So let's go with GPH BP layer. Oh, it's not layer interface. Oh, wait a minute. Is this, have they made their own one? Is that what this code at the top was? Yes. Okay, fine. So I now need to create my own broad phase layer interface. Have they really not got a default one? That's a real shame. Like, I was kind of hoping they might have a default one. So what does this do? I thought that was a typo, but it looks like they've lined all their member names on that column. Create a mapping table from object to broad phase layer. So they have whatever this is. So this owns the broad phase. This owns a bunch of broad phase layers. And so it's an array of broad phase layers based on whatever this num layers is. And then this sets the non-moving one to be non-moving and the moving one to be moving. And then get the number of phases, get the broad phase layer. So the in layer turns this. And then I don't care about this. Okay, that seems fine. I think. Broad phase layers. Here we go. What's this? Sorry, a little bit of dots reading today. Yeah, I also saw that there's an option that switches out their internal array for std vector. I'm going to leave it as default, but we might want to switch it on to make life easier for us. It really depends how much boilerplate we've got. So each broad face layer results in a separate bounding volume tree in the broad phase. You at least want to have a layer for non-moving and moving objects to avoid having to update a tree full of static objects every frame. Okay, fine. So you can basically, so there's, in a physics engine, there's a concept of like static and dynamic objects. So the static ones are like your level geometry. They don't move. They're always in the same place, and no force can act on them to move them. They literally exist there. They effectively have infinite mass. And aren't affected by gravity. They exist for collision detection and response, right? So so you can walk up the stairs and not walk through walls and stuff. So this is saying that their broad face has multiple layers, and you put different objects in different layers. So you put all your non-moving objects in one layer. So presumably it can optimize that away. So it doesn't have to update a tree full of static objects every frame. So every frame, it's not going to say, okay, which of my static objects intersect, because they'll never intersect, because static objects don't participate in that kind of resolution. They're only for intersecting with the moving objects. You can have a one-on-one mapping between object layers and broad face layers, like in this case, but if you have many object layers, you'll be creating many broad face trees, which is not efficient. If you want to fine-tune your broad face layers, define... Okay, I don't care. I'm not sure I care too much about this. I kind of feel this one seems a little bit strange anyway, because this is returning... What is this broad face layer object? I guess that's what I'm kind of interested in. Is it an integer? Because what? Because I feel like why do you need a map at all? Maybe for this, but like, why can't this broad face layer just return? Like, why can't you just switch on this and just return like these numbers? I'm kind of interested what this does now. Can I? Broad face layer. Okay. Broad face layer. Here we go. Is this in here? Broad face layer interface. The broad face layer constant values to indicate an invalid broad face layer. But what is class? Oh, it's a class. Okay. An object layer can be mapped to a broad face layer. So it takes a uint 8. Is this just... I think this is just a wrapper around an integer. Right? So I'm kind of doing a little bit of dive on the code as well, because I'm interested in how it works under the hood, and part of this journey is to kind of get a bit of an understanding of how these sort of large, complex code bases work. And this is how I kind of meander my way through an unknown code base. So it defines a type, which is uint 8, has a default constructor, and an explicit constructor which takes one of these types and stores it in m value. It then has a copy constructor, copy assigner, copy assignment, a quality operator, not a quality operator, less than, and then type. Well, it's not really an improvised class enum, because there's no naming of the, like, an enum is a range of integers which you assign like a contextual name to. This is no naming. This is just like, I guess you could use it like that by naming the object that you construct of the actual reified broad phase layer object, but like there's very little difference between this and an int, other than I guess it restricts all the mathematical operators. So I guess it has two advantages. One, it gives it a name, so rather than having a random int floating around, it's like, oh, this is a broad phase layer, and this has some semantic meaning, and I can't do any other operations on it other than comparison. I can't add two of them together, for example. Interesting. Okay, fine. Well, at least I understand that a little bit better now. Apologies for the diversion, but I think it's kind of interesting to go through. So this, yeah, okay. So this is saying I'm going to have a non-moving layer and a moving layer. And I get the object layer in. Again, I don't know what an object layer is. Is that something similar? Because it uses this like an integer. So is this implicitly convertible to an integer? Here we go. Oh yeah, so it's just a number. Okay, fine. So I think, I don't want to go too off-piste on this, but also I don't want to copy too much of this. I think we could create a broad phase layer interface which just returns in layer and casts it to this. So I think, right? That is fundamentally what this is doing, right? It's got an array, a fixed array of two objects which are int wrappers, and then it takes an integer and then it returns the one at that index. Yes, I am using WSL. So I think up here we can do. This is the. Where did I find that collision object? I've already lost it now. Broad phase. Broad phase layer interface. So that's in. So hash include Jolt physics collisions broad phase layer, and also I should have to include Jolt physics system, and I was told to always include Jolt before. Thou shalt include Jolt before any others. Don't need that for the moment. That's true. Okay, fine. So now we can write some code again. I could be wrong. This might not be the right way, but this feels to me like I want to just do class. Let's go for like simple broad phase layer is public JPH broad phase layer interface. Why is it not like that? And then public, what do I want? Virtual. I don't really want to use their uint type because I don't know what it. Yeah, okay, that's fine. JPH uint get num Broad phase layers. Broad phase layers. Sure, sounds good. Const override. Return 2. And then so this comes up every time, and it's a great question, and I'm happy to answer it every time because one, I think it's good to let people, it's good to talk about it, and two, it normally means someone's new to the stream. So budget arms, if you're new here, welcome, glad you're here. This just means the global namespace. So everything that you want to access, including stud, exists in the global namespace. I preface this for two reasons. One, it instantly opens up the autocomplete, which is kind of handy. And two, I access everything I didn't write through the global namespace. So it means when I'm scanning the code, at a glance, I can see, oh, this isn't my code because it starts with the global namespace. If we look at, for instance, in the window class, where we do a lot of Windows code, you can see here, I've done this, there's loads of places where this happens, right? Because I didn't write this function, I didn't write this function, I didn't write any of these Windows functions. So at a glance, if I'm just scanning the code, it's like a visual indicator to me that this is code I didn't write. You don't have to do it. I just have always done that. Virtual JPH broad phase layer get broad phase layer. Well, actually, what am I doing? This breaks my my naming conventions, and I might as well stick with what I've been doing. That's better. Right. Get broad phase layer JPH object layer. They've called it in. I was going to call mine layer, and this is a JPH broad phase layer. Oh, lots of typing today. And why is it not like? Let me just close this window down. Why is that incomplete? Yeah, like I said, it's pure convenience for me and just a personal preference. You don't have to do it. It's nice that auto there is if you want to call a free function from a class member function that has the same name, then you will need to use it to disambiguate the two, and that's when you do actually need to use it. I'm just going to finish writing these methods, and then we'll get the compilers to tell me where I went wrong. I suspect I've not included the header for this correctly. But we shall see. So let's return static. Nope. Let's just return. I think we can just do that, right? This will construct a broad face layer, which has an integer constructor, which this is an alias for an integer. Something. C++. I'm reasonably confident that'll work. I think that's the only one we need to do. So this in theory this should blend, but I don't think it will. I specified two types in that function. Oh, I did. Well done. Yeah, I'm using MSVC, but the wine version of it, so I can use my Linux toolchain to cross compile for Windows using the actual Microsoft C compiler. Is it ideal? No. Does it work? About 99% of the time. What have I missed? JPA issue. Okay, something is amiss here. Oh, it's because this core. What's this core doing up here? Why MSVC? I prefer to use the compiler for the platform one. Also, MSVC, it has gotten better, but MSVC tends to have the best library support for modern features. They tend to be the first to implement like C++20, 23, and 26 library features. So not necessarily the language features, but they tend to be pretty good with the library stuff. So it's kind of nice to have that. Have I saved the header file? Almost certainly not. Oh, I have this. I have this time. Oh, what's this doing? Oh, Matt, I'm getting a bit annoyed with Clang D here. It keeps including random header files for me in places like I don't like. Another interesting design choice of Jolt is that it has header files that has to be included in a specific order, and that's just normally a recipe for disaster. But here we are. I'm not generating makefiles or SLM files. I'm using CMake to generate Ninja files. Yeah, Microsoft's normally the first to fully implement the library features, not necessarily the language features. Does not override any base class method. Are you sure? I've got like a Vim. I had a binding which in NeoVim which opened up. It followed the tag but in a split pane, and I can't remember what I mapped it to. Nope. Oh, never mind. I'll do. Why is that not following? Here we go. Right. Get num broad phase layers const. Doesn't like that uint. Yeah, it doesn't know what a uint is. It's got to be their own, like, it's got to be their namespaced one, right? Surely. Also, it doesn't like this one either, which is... Oh, this is because this... no, get broad phase layer returns broad phase layer. Oh, I see. Was that what the... You're right. Okay, fine. Using uint is an unsigned int. I'm going to assume this is in their namespace. Ugh, sure. can't see what I've done wrong. Unless it doesn't like mix. Does it? It can't. It's not. Surely I can mix naming conventions. Oh, I can't. How interesting. Well, oh no. Is that really the case? How interesting is that? That is absolutely fascinating. Well, this doesn't seem to think I have access to broad phase layer at all. How much can you say about what you imagine your game to be overall? I can say as much as I know, and that is not a lot. I'm thinking of some sort of like movement, like sort of puzzle game. Like you have to kind of like move the barrels around with some interesting mechanics on how things move and when. So you kind of have to sort of plan out your moves. That's kind of what I'm thinking. So like almost like Portal kind of. You've got like fixed like levels that you kind of have to work your way through. I don't know what Hop Slide is, so the answer would be no, I've not played it. So can't use an explicit fine. JPH broad phase layer. Has it moved it again? Oh, it's moved it again. Oh, it's because it's alpha. It's gonna. This is the problem. I have my include set up to be automatically sorted in alphabetical order, and then that breaks when you have to have an implied order. Is that now narrowing? Yeah. Okay. Fine. So there's a couple of things. I maybe kind of just whiz through a lot of code there. So let me just take a second to kind of go through what was happened. I have been trying out a new style for declaring functions called the trading return type. So everything is auto, function name, and then the type on the end. You don't have to do that. It's not that common. I wanted to use this as an excuse to try it, so I've been using it everywhere. It turns out that it doesn't like mixing and matching that style when you are when you are extending a class. So that's interesting. I didn't know that. The other interesting thing is here. C++ has a multitude of ways of initializing variables. In fact, we tend to get more with each standard. I think there's now 22 ways to initialize an integer, something like that. In C++11, they introduced the braced initializer, the one true way of initializing to rule them all, which doesn't work in all situations. But what this does is it prevents narrowing. So this here takes a uint 8, and this here I think we ascertained is here goes it's going to be uint 16 or uint 32. So this would involve narrowing a 16 or 32-bit number to an 8-bit number, and that is not allowed. This explicitly prevents that. So we can either downcast it ourselves, or we should just be able to use the round bracket, the old style, which does allow. So the old style does allow you to do an implicit downcast, and the new one doesn't. So you can kind of infer from that the braced initialization is slightly safer. It prevents you accidentally like slicing your numbers off. But in this case, I'm going to pretend that I know what I'm talking about and say I actually want that. Do I have any idea how two applications communicate to each other, and do APIs have to run in a local server to achieve this functionality? So what you're looking up there is something called IPC, or inter-process communication, and there are loads and loads of ways of doing it. There's like named pipes, there's shared memory, there's just like the file system. How process there's like literally just look up IPC, Windows IPC, and there's loads of ways of doing it. The clipboard you could probably potentially use. Like the clipboard is an IPC mechanism, right? It allows you to communicate data between one process and another. So, okay. So now what I've realized now is I now need to construct one of these, and I need it to live as long as the physics systems. I've actually spent all that time and actually put it slightly in the wrong place, because I now need to construct one of these. Oh, there's a lot going on today. Dbus. So I've got a choice here. I'm going to talk you through my process, like what I'm thinking. I can move this declaration, stick it in the header file, but it does mean that everywhere that we include the header file, we're also unnecessarily bringing this in. There's three options. I could stick this in a separate header file, thus effectively kind of, well, that's exactly the same problem as here, right? Because it's going to transitively include it. And it's more, it's just exploding out all of our files. I mean, files are cheap, I'm not too fussed about it. Or we can use the Pimple idiom and just completely break the dependency on this class here on Jolt, take all these headers out, stick them in the implementation, but we will have one dynamic allocation. I'm trying to think which of those I hate the least. Because we're going to have to do this multiple times, I suspect, looking at their code. What other rando objects do we need to create? We'll need an object versus broad face layer filter. We'll need an object layer pair filter. It's just those two. Yeah, so I do like the idea of keeping, I do like the idea of abstraction, where all the misery is pushed down into the CP file and the header file is quite clean. I'm not using an article, I'm just using the Hello World example from the physics engine from Jolt. I'm just kind of going through their code and piecing it, like sort of trying to tease out the useful bits. Yeah, it's kind of choosing between two of the bad options. The anonymous namespace is because it restricts this. This is the other thing I like, is it restricts this type to this translation unit, which basically means no one can accidentally, no one can see this outside of this CPP file. It doesn't introduce that type into the type system. Same if I had a function in there. It's the equivalent of, well, I mean, you have to use anonymous namespaces for type declarations, but if you have, it's the equivalent of having like a static function or just a function in an anonymous namespace. It just it creates internal linkage. It just restricts it to this CPP file, which is kind of by design, right? This is purely an implementation detail, and no one should have to worry or care about it. So I think I might do Pimple, purely because I want this class to be non-copyable anyway. One teeny tiny dynamic allocation is really not going to be a deal breaker. And it does mean I can push off all the misery. I think. Is that what I want? Just what is the... I feel like I'm now wasting time not actually making any progress because I've got myself stuck in analysis paralysis over two choices which are, at the end of the day, don't actually make any difference. I'm gonna go pimple. Okay, so now we can do struct physics system implementation and then we can move this over to here, get rid of all this. I don't tend to add the prefix to that, and then we can have simple broad phase layer, broad phase layer. And then this becomes import stood make unique implementation. And then we can do import physics system, and then at the end here we can do the address of import broad phase layer, I think. Okay, a couple of questions come in. So why do I define it in the CPU file? So there's an important distinction here. I've not defined it, I've declared it. So there's a distinction in C++ between declaring and defining. Declaring just says there will at some point be a thing called this. Okay, and you can do that with types basically. So I can say, look, hey compiler, don't you worry about what this is. Make it the linker's problem. At some point in the program, when it all coalesces at the end, there will be a struct called implementation in physics system. And you're kind of limited to what you can do with that. It's called forward declaring. You can have a reference to it and you can have a pointer to it because the compiler knows enough to be able to construct a pointer or a reference to it. I can't use this in the header file. I can't allocate it as a member. Unique pointer is made such that you can have a for declared type. I can't remember the exact words they use in the standard. Partially incomplete type. So this is all legit. And then over here, so that's the declaration over here. I define it, okay, here, and so this doesn't violate ODR or anything like that. And then this just exists in this translation layer. So again, when the linker comes to sort of zip everything up together, it will find this and sort it out. So that's why that's kind of the difference there. Pimple is a idiom in C++ called pointer to implementation. It basically allows me to offload the effectively what it allows you to do is offload declaring the member variables to the CPP file. That's effectively what it does. So now I can declare all my private members here in this struct. I have to dynamically allocate it, but then I can access everything through impl, if that makes sense. And the struct doesn't need to be static. If it were static, then every single physics system would share the same implementation. And whilst we are only probably going to want to create one physics system, if we were to create multiple ones, then we would want them to have separate implementations. So So the other thing is, why don't you just stack why not I just basically create a buffer here and placement new or stood construct at into it. So you could do that. I just don't know how big it needs to be. And like for a thing that's going to be initialized once, okay, I'm totally happy with a dynamic memory allocation. Like this here is also like, if someone, not that anyone would, but if someone else to read this code, this is a reasonably well understood C++ paradigm or idiom. People would understand this. If I had something like like 102.40, right? And then somewhere in here I had stood construct at I can't remember the exact rules, but it's something like that. I can't remember what it is. Like that is not obvious. If you just look at the header file, be like, oh, there's a big buffer there. Then like, oh, I've got to dig through the constructor and find this like thing. I mean, or placement new or whatever you want. New buffer implementation, something like that. I can't remember the exact runes for it, but yeah, I think that's like less obvious. And again, to kind of like, I'd pay the price of one dynamic allocation to not have to worry about that. I think the question is like, will this involve cache misses? It's kind of hard to say without like profiling it or really thinking about it. Again, I'm not fussed about it because I suspect most of this will just come up against just calling like a few points on this. So I don't know what we would get. You know, we're going to mainly be calling members on this. This is just to store the data that we need for this. So I don't think, like, I don't know what we would be bringing back in that cache line that would be useful to us. But it's a good point. It's an interesting discussion to have, and like if people have never heard of like placement new before or stood construct at, then it's kind of, you know, it's interesting to know about it. But yeah, the point of moving this all over to here is that now I can keep these types local to this translation unit. It doesn't leak out. It keeps the abstraction much tighter. This header file has like nothing to do with Jolt at all. So in theory, anything that includes this will potentially be quicker to compile. So there's lots of trade-offs, but this is kind of where I'm at. And I just want to make progress. Okay. This hopefully still doesn't compile, but at least in the place I'm hoping it doesn't compile. Oh, it still doesn't like this. So the following warning street is an error. Line 22. Conversion from object layer to base layer type. Possible loss of data. Apparently I still have to do this. APH raw face layer. I think does it expose the layer type? It's type, okay. Raw face layer type. Why is it? I feel like I'm struggling with like a very simple part of C++ here, and I don't know why. You're not because you can't use the explicit constructor. Okay, fine. So I need to combine both. Okay, fine. Right, are you happy now, compiler? I felt like it was just a huge amount of boilerplate to just convert one number to another, but here we are. Cannot instantiate abstract class. Const char get broad phase layer name. Const is abstract. Why can't it construct it? But like, if it's abstract, then that means it provides a default implementation for it, right? What one was it complaining about? Get broad phase layer name. Oh, is this? It is const. I think it's this. So if we look at their example, they're like, oh, if this is defined, then do this. So I guess those are defined, like one of those is. So what's their implementation do? Oh, this is the mapping. This just returns these as strings. That's fine. So we can do virtual const char. In fact, actually, I really hate this kind of like hash defined nonsense. Like, you know, this function only exists in these specific situations. Like, I know sometimes you need it, but like, I just think it makes the code so gross. Right. So const char star get broad phase layer name jph broad phase layer const override, and then switch on layer dot get value. That's terrifying as well. They just straight up C-style cast their entire object back to the underlying type. So I mean, that's great as long as it's unless it's got a cast operator I missed. That doesn't feel great. But would that work? Must have a cast operator I missed. Anyway, I'm going to use get value. Case 0 return non-moving. These are just their example ones. Case 1 return moving. I don't need the break, do I? And default include error.h throw notes game exception unknown broad phase layer. Cool. Okay. Hopefully that's right. That's now disappeared. That's in there. Whew. Right, we're getting there. So I want init. That took longer than I expected to create that one. Unknown. Okay. Okay. We've got the broad phase layer. I don't think we'll be doing anything graphical today. I mean, don't all like disappear at once when I admit that. But I'm happy to go for a little bit longer just to see if we can. It'd be nice if we can just construct something and maybe log out that some physics is happening. And then Wednesday we can add in some visual information. Also, I just noticed there's all this chuff as well, like register allocation hook. Just create a new factory. Might need that. Register type, like random free functions. What we'll do is we will bury. So these feel like things that need to be called like once at the start of the program, or at least before you create your first physics engine. So any of those we need, we'll just put in like a static flag here, so that it only gets called on the first physics system that gets implemented. Because I don't know, we might want more than one physics system, or like you might want to tear it down and create a new one between levels. I don't know. Making this up as I go along. Right. Okay. So the next thing is the object versus broad phase layer filter. And they have a object versus broad phase layer filter impl. So create a class that filters objects versus broad phase layers. As it's an interface, we'll take reference to this. Also have a look at the. So there's a simpler. So also have a look at the filter table or the filter mask for a simpler interface. How complex have you made it? Okay, layer filter. Okay. This looks okay. Should collide. If it's non, I guess 2 layers. Right. So this is the mapping between the layers. So the engine's going to be like, right, there's these 2 things on these different layers that are colliding. What should I do with them? And it basically says, if one's non-moving, then they should collide if they're moving. Else, if they're both moving, true. All right. If the first one is moving, always do the collision. If the first one is non-moving, then only do the collision if the second one is moving. Got ya. Right. Guess we're gonna need another class. It's kind of interesting seeing the advantage of going through all this misery of trying to construct it all is that we can kind of pull out some of the design of the physics engine and get a feel for how it works under the hood. Like, okay, I can kind of see, there's a broad phase, and we can like organize stuff into layers, and we can kind of control how they work. I would probably want to write my own renderer. I suspect that it does support, because it has all these. I'd be very surprised if there wasn't some sort of debug interface that we could, like, that's how Bullet does it. There's a class that you implement, and then it basically just sends you all the line data that you want to render. And I would want to integrate that into our own rendering pipeline that we've already got, just because I think it's interesting to do, and again, gives us a bit of feel for what's going on. So I suspect we'll probably do that. Simple object versus broad phase layer filter. What could go wrong with this one? APH object versus broad phase layer filter. Okay, right. Where does this hot mess live? Collisions. Hash include Jolt, physiques, collisions, broad phase, object versus layer filter mask. What have they included? None of them. Great. Oh, it seems to have satisfied it. virtual bool should collide JPH object layer 1 juf object layer 2 const override, and this should just basically return layer 1 equals 0 or layer 2 equals 0. Right, if either of those are the, oh sorry, I've already, that is a bug. I should definitely name these. If either of these are moving, then you should do the collision. Oh, because it's, oh, I've just not read this. It's the object layer and then the broad face layer. So I think that's right. Okay, fine. Right, now we're getting somewhere. So my other simple class. What did I call it? Simple object filter, and then what? Object. Oh my goodness, what have they called theirs? Literally the whole thing. Okay, fine. Object versus broad phase. I guess the clue is in the name. It is the object versus the broad phase. So it's okay, fine. It's not object versus object. It's like this object is in this layer. Should I bother handling the collisions for it? Not should I check the collisions between these two objects. It's should I even bother doing anything with these? So that makes sense. Okay. Right, now we're getting somewhere. Now we want the broad phase layer. Sorry, I just realized I'm leaning past the mic. Okay, I want the object versus object layer filter. So this is right. Okay, fine. So this is basically what I thought I was doing before. So this takes two in objects and says I think it's basically the same thing. Simple object layer pair filter. Simple object layer pair filter. And this will be object layer pair filter. And it should collide object layer 1. And this is object layer 2. And this is the same logic. Either of them are moving, then they should collide. And now I want another one of these. Simple object layer pair filter, object layer pair filter, And then what's this going to be? At impl object layer pair filter. Oh, right. Okay. So I think that's the last one. So oh, does it just take my reference? Am I being silly? It does just take my reference. Okay, that's fine. That's even easier. So we don't even need any of these. Nailed it. Hello. It's the quick poll for everyone, I guess. Oh, never mind. GCL0 subscribed. Thank you very much. Much appreciated. I had to remove the. I had like a rug in the office, and I had to remove it. Is the audio echoey at all? It sounds echoey to me, but this is a pretty good. Like this mic is pretty decent. I don't know if it picks it up, but it'd be interesting to know if the audio sounds worse than it usually does. Also, just check everyone's still paying attention out there. Pretty fine as normal. Sounds good. Brent, thanks. Yeah. I just need to replace it. That was all. Brent, yeah. Because I have a tiny office. It's sort of like 2 meters by 3 meters. Yeah, probably pretty close to that. And I had issues for ages when recording videos of just like terrible. I can hear it now. Like terrible echo in here because it's hard floor. Hard wall ceiling. But this mic is really good at filtering it out. Hello. Okay, right. Okay, we've got physics, right? What could be left to do? Okay, there's some chuff here. I think we should probably go through and actually do all this chuff. So we want to register the default allocator. So register allocator hook. In this example, we'll just let Jolt use malloc free, which is fine, but you can override those. Do I want all the tracing stuff? I feel like we're probably going to want it. I feel at some point something's going to go wrong, and we'll need to trace. In fact, actually, let's set up the tracing because that way we can kind of check everything works. So let's go back to this. I already hate this code. Jolt trace const char format dot. I'm wondering if I can I do it with a template or I don't know how they've gone about it. Also, what is that? So, sorry, I'm just looking at their trace code. So they've got this trace impl which takes a variadic. But this is basically how printf works, right? So you have to do this variable list and get all this stuff, and then listen printf it into a buffer, and like, ugh, no one wants to do that. But they just do like trace equals trace impl. Like, what is this trace? This must be some sort of like global. It's not defined anywhere. So I was just wondering if I could get away with maybe doing a template instead. Yeah, I know, I saw that, but thanks for pointing it out. Where is... Let's just... fine. I don't want to spend too much time on this because it's not that important. In fact, actually, I think I might just yoink that out. Let's see Stadog when it's at home. And then we can just wire that up into our own logging library now. So we can just do game log info Jolt trace buffer. And then they just do like APH trace equals Jolt trace. I'm hoping we can find whatever that is. Oh, okay, fine. It's just an extern. Okay, I don't love it. I don't love it, but it's fine. I think we have to conform to that function signature with the variadic. I don't think we can use a template because it's an extern, which means somewhere else the places that reference it won't have access to the template definition, so they won't know how to expand it, I think. They also have this. But they have like suppress warnings, but I think we'll keep those on for the moment. Okay, what's this other setup stuff we need? So let's do, I think before we get into this, let's do static bool once equals false. If not, once. Equals true. So this here is just a little, well, it's not really a trick. This just allows me to run code. Whatever is in this if statement will only run the first time this object is constructed in the execution of the program. Every subsequent physics systems will skip this code because it's a static bool. So this allows me to do all their kind of like setup chuff just once. And again, I'm trying to build an abstraction, so I don't want my main code to be polluted with all this, right? Part of me building an abstraction is I kind of bury all that down behind and hide it behind something. So in this case, the physics system, main doesn't have to know. It will create a physics system, and if it needs to do some setup internally, it will do it. And if it doesn't need to do it, it won't do it. We'll register the default allocator. We'll do that. And then we'll do this is interesting here. Create a factory. This class is responsible for creating instances of classes based on their name or hash, and is mainly used for deserialization of saved data. It's not directly used in this example, but it's still required. So this is a memory leak, right? Because if I just do auto factory equals new JPH factory, then nothing's ever going to clean this up. I think I want static think I want a static std unique pointer. But it doesn't matter because it's the end of the program is going to come and it's all going to get cleaned up anyway. But I just can't, like, there's something about just like allocating, like calling new and then just like not managing it. It doesn't sit well with me. Of course, that's not thread safe. If we create physics systems from different threads, then that will clash. But yeah, so this static means that it's only allocated once. So it means every because the constructor is just a function, right? It means every invocation of this function will always see the same variable, and it will always be at the same address. It basically means it's allocated somewhere outside statically for you, and they will see the same. So on the this is thread safe, I think. Like, if multiple threads arrive here, only one of them will get past this line with it being false. Oh no, wait a minute, no, I'm thinking of something else. No, it's not thread safe, but it doesn't really matter. So yeah, anyway, I feel better now that I haven't done that. So register, sorry, JPH register. Oh, do I not register? Do I not have? Where's register types when it's at home? Ah, interesting. I'm missing some headers. I finally need some more of them. Register types. Okay. Yeah, you're right. I do need atomics. Sorry, I was getting confused with the static way of doing singletons, which is thread safe, but that's completely different. It's been a long day. So we need a temp allocator for temporary allocations during the physics update. We're pre-allocating 10 meg to avoid having to do allocations during the physics update. 10 meg is way too much for this example, but it's a typical value you can use. If you don't want to pre-allocate, you can also use temp allocator malloc. So I suspect this is used. So this is used in an update. Okay, so that's fine. So that will be that'll be a member or in our pimple, and I guess job system is probably the same. That's also an update. Okay, so we can create those as part of this. So that was JPH temp allocator. So it's actually temp allocator. I don't know, follow their name convention, I guess. Allocator, and then I want JPH job. Header. Oh, it's funny how some of them must be some transitive includes somewhere, because like I didn't need to include temp allocator, but I did need to include job system at thread pool. Let me hang on. What's going on there? JPH job system thread pool. Job system. Job system. Oh no, is that just realized it's an impl. Means I've got to probably create my own one. Oh no, do they provide that for me? They do. How nice of them, in fact. That has a non... Oh, it is explicit. That's annoying. That's the only annoying thing with the pimple idiom is I now have to effectively construct those and then assign a new one over the top. Unless I created a constructor for this, but I can't bother. So this will equal JPH temp allocator import. They're going to go for 10 times. Well, U times 1024 U. Kind of. Oh man, such pain. Can I here do JPH temp allocator info 10U times 1024 U times 1. That's okay, fine. I'll just do it in line. Okay, and then job system equals JPH job system thread pool, and then they gave it max physics jobs, max physics barriers, hardware concurrency. No, this one. So hardware. I think they've done using namespace stood, which is never a great idea, but I guess for a simple example, it's not the end of the world. Hardware concurrency returns. Well, it's not. I don't think it's guaranteed, but effectively, it returns the number of cores you have on your machine. Effectively, I think there's some more nuance to it, but if you have an 8-core machine, that will return you 8. So this is basically saying 1 minus the total number of cores you've got, which makes sense because you'll be running in a thread. So this will only spin up presumably n minus 1 threads, but n is the maximum number of cores you have. So you've got your main thread on 1 core, and then the rest can all be put on others. I mean, obviously subject to your operating system job scheduler. No, not write my own physics engine. Yeah, exactly, yeah. It will leave 1 thread free for the game. Okay, so what have they got for their magic numbers? Where's this? C physics jobs. Oh, interesting. I think those might actually be already defined. Oh, interesting. Okay, fine. C max physics barriers, and then include thread, stood, thread, hardware concurrency minus 1. Okay. Okay. Yeah, sorry. Yeah, I know there's like I said, there's some nuance to it. I always think of it as number of cores, but obviously, hyperthreading, that kind of thing. Yeah, like I said, there is more nuance to it. Okay, so I think we're getting there. I think that's all the setup stuff. Oh no, we're not quite there yet. So we are in line with their example, and having run absolutely none of it, so no idea if it works. We are now here, so we now need to create an oh no, I don't think we want an activation listener. Yeah, I don't want any of that. I now want the body interface. Where is this used? Because it's a reference, which means it's going to be an absolute pain for me to use anywhere. I think I can get away with... No, I'm going to need that. It's a reference. Where am I going to put it? I have to probably use reference wrapper. Okay, fine. GPH. Third reference wrapper. GPH. Body interface? Question mark? What design? If it's... might not need it actually. Yeah, we'll just call it every time we need it. There's no point storing it. So, sorry, where I was at there, I don't know if someone's mentioned this, is you get this body interface. So the main way to interact with the bodies in the physics system is through the body interface. So this returns you an interface, presumably virtual, some sort of... so you don't have to worry about the implementation details. And then from here, we create the bodies, we add the bodies, and then we get the velocities of them and stuff like that. But I'm going to assume, let's check the code, but I'm going to assume that this is a cheap operation. So we can just call this whenever we need to. It'll be in physics system, won't it? So where's... is it? Our physics system.h. Yeah, okay, fine. So I'm going to assume that that is a cheap operation. Auto body interface equals import physics system dot get body interface. Next, we can create a rigid body to serve as the floor. We make a large box. Yes, you can do auto there. It doesn't actually make any difference because it will infer it, but I think, was that what it was? Oh no, you're right, sorry, it's the pointer that it will infer. Good spot. And then I want auto, so basically what I'm gonna do is I'm gonna write some simple physics code that just does a thing, that just simulates something in the constructor, and then in the next stream, we will abstract all that out into our own like rigid body classes and shape classes and stuff like that. But I just want to kind of see if I can just get something logging that we are doing physics things. So this is the auto floor shape setting equals GPH. Right, more headers. What am I missing now? I probably should just include all those because body creation. Here we go. Oh, what is going on? I really wish. I don't know how to tell ClangD that when it finds a header file, which ones are project includes and which ones should be system includes, but problem for another day. Right, so now hopefully I have box shape settings. I do. And that will be a JPH vec3 100.0f 1.0f. Okay, so I've got that, and then we want to do floor shape settings dot set embedded, which sets some sort of reference count. And then now I need to create the shape using the shape settings. I think Bullet has something similar. Like you have a definitely have the concept of a shape which you create a rigid body from. I can't remember if you have the shape settings. Auto floor shape result equals floor shape settings dot create. And then I can do auto floor shape equals floor shape result dot get. Okay. It does say in the docs that there is a has error we can call here, but it says it doesn't expect there to be errors in this case. Maybe we should just ensure floor shape result is valid. Valid. Just because, you know. Okay, right. Ah, someone here from the Worms 2 community. Nice, nice that you're. I'm glad you're here. Okay, right. So now, create this. All right. Okay. So let me just bring up what I'm reading. So I've created the floor, the shape settings. I've created the shape. I now need to do the settings for the object, which presumably is its like position. No idea what an rvec3 is. Its orientation. I thought it said a motion type, but I assume that's emotion, like enum motion. It's got static emotions, and it's in the non-moving layer. We should definitely put these in an enum or something, because passing random numbers around is going to get incredibly confusing. Rotation vector could well be. Could well be. Yes, cool, thanks. I need this to get access to the literals. Good spot. Okay, right, well, let's just copy some of this code and see where we get to. So I now want auto floor settings equals pH body creation settings. And from this, I want the floor shape, JPH of real vec3. Not R. Minus 1.0 R. So that's going to create this box and move it down 1. So I assume it's 1 high and it's moving it down 1. So the top will be resting along the origin. And then JP. This will be, I think this will be nice. Once we get our abstraction in place and we don't have to worry so much about all this gubbins, I think it'll actually, this should be quite nice to work with. My emotion type is, definitely don't have dynamic emotions at the moment. And then I want the, and I've already forgotten which one it was. I think the non-moving layer is, sorry, the moving layer is 0. Nope, the moving layer is 1. Okay, fine. I will I will improve that next stream. For now, just want to kind of see if we can get something working. What have I done? I got too many closing brackets. Okay. Okay, fine. So it's for setting floats doubles. That's fine. Okay. So now we do auto body. Sorry, auto floor equals the body interface dot create body floor settings. Okay. And then we add it to the world. So we're going to go body interface dot add body floor get ID, and then JPH E activation don't activate. Sure. And now all we need to do is create this ball, which obviously doesn't mean anything to, we don't need a ball at the moment. I mean, so we'll just create a ball, not that we have any representation of it. Okay, we're nearly there. We're all right for time. Go for another half an hour, I reckon. Yeah, I think we're getting there. How can we make sure the units of measurements from the physics are equal to the rendering one? We'll make it so. I have no idea. We'll figure it out as we go along. I think renaming floats to reals is quite common because Ogre does the same thing. It has a real type, and then you can define whether a real is a float or a double. So if you need greater precision at the expense of performance, then you don't have to go and rewrite all your code. You basically just say, all right, all my floats are now doubles. So I suspect that's why they've done it. Like I say, Ogre does the same thing. Okay. Auto sphere settings equals JPH body creation settings. Apparently this one just takes new sphere shape. I assume that's correctly cleaned up at the end. JPH RVEC 0.0 R. Put this a bit higher. To be fair, I would probably, if I wanted to support both floats and doubles and make them interchangeable, I probably would do something similar to this. I think it's actually quite a nice solution. JPH quat S identity So this is now going to be dynamic. GPH E motion type dynamic. So this will be layer 0. Auto sphere ID equals body interface dot create and add body. Nice. I think this example is showing you that there's multiple ways of doing something. You can kind of do it the long way or the short way. So that's good to know. GPH E activation activate. Okay. And then body interface dot set linear velocity of the sphere ID, and then GPH vec3 0.0 f minus 5.0 f 0.0 f. So this just gives it some downward velocity, so it's just falling. And then impl gotta optimize that system. Got to optimize that broad phase. I don't know if you're supposed to call this. I suppose I could read what it says. Optional step: before starting the physics simulation, you can optimize the broad phase. This improves collision detection performance. It's pointless here because we only have 2 bodies. You should definitely not call this every frame or when streaming in a new level section, as it is an expensive operation. Instead, insert all new objects in batches instead of one at a time to keep the broad phase efficient. Okay, good to know. Right, that's done. Who owns the new? Your guess is as good as mine. I'd have to go through the code and figure it out. So now, let's check that blends. I feel like it's been a while since we compiled it. Am I planning to make this game multi-threaded? I have no plans, but I will if we need to. Again, I'm just trying to write code that we need, rather than code I think we'll need. So let's do physics system update. So this needs to do 1 tick of the thing. So should be able to do impl physics system dot update. Delta time should be 1 over 60.0 f. I know it gets converted to a float, but I'll keep them both the same. JPH C. What's C collision steps? Oh, it's literally the line above. It's 1. The address of impl temp allocator, the address of impl job system. Do I keep notes after every session? No. I have a Trello board that I throw stuff into when I remember, but I'm kind of just figuring it out, making up a lot of this as I go along. It's been 36 minutes since last compile. I'm just interested that you're keeping track of these things, or unless you saw it on here, maybe. Okay, right. Okay, so let's. We can now do hash include physics system. Okay, and then we'll do auto PS equals game physics system. And then we're gonna do, let's see, so we'll process the input, we'll do the what's the best way of doing this? I want to process the user input, I want to simulate the game, I want to do the PS dot, I want to update the physics, and then I want to render it. Use of undefined games physics system implementation. Oh, classic pimple. Whilst unique pointer will accept an incomplete type, this class will try and create a default destructor and then be like, I don't know how to, and then the way that the code will get compiled and it has to lay out, you know, the unique pointer and everything, it'd be like, I don't know how to destruct this. So what you basically do is you have to say, don't worry, I will tell you how to do the destructure, what the destructor should be later. So this will now compile, and then in the CPP file, you make it like, oh no, it's just gonna be the default one, because at this point it knows what struct implementation is. It's a pretty common gotcha with the pimple idiom. I'm looking at the body creation settings header and the constructor is empty. I will have a look in a minute, I guess. I'm sure. I mean, I don't know. It's the first time I've ever used this code. I guess we'll just run it. I'm not going to do a poll because I've absolutely no idea what's going to happen. So run it and see what happens. It sure did crash. And it sure did tell me nothing. Well, that was pretty dire. I don't want the TS callbacks. Just go. Run. Be free code. Exception access violation. I mean, none of that looks like my code. Run the game. Right, where's just... It's definitely running the executable because it's created the window. Why is that? It's probably running it from that directory, so it needs to go up. It's in there. So it's in the source directory, up 1, up 2, into assets. So that should be fine. Why is it having a... When I get to main, Sorry, there's a bit of live debugging as I try and figure out what's going on. Main. Stop there, please. Okay. Right, okay. Debug. Right, so... Well, I'm going to assume it doesn't like physics. Because that's the new code, right? Where am I now? Physics system. Okay, fine. So let's do step in, step in. Right, okay, so this is the start of physics system. Got some source code. Oh, wow, that immediately... Where was that? Doesn't like... Hey? Is it crashing on? Oh, interesting. Potential issue is that it could be making Jolt objects before this. So let's... Right, so now let's do... Depending on how important all this stuff is. I'm not going to spend too long on this. I know it'd be a little bit disappointing, but it's already quite late. Row. It's definitely in some sort of static initialization. Let's try that again in the debugger. Now that I've got this, let's go 7. Yeah, it doesn't like this new factory. Why is it not like that? Let's just check it's not me being silly. Let's see if I missed off some sort of initialization code. No, it definitely doesn't like that. Oh, no, this is a static object. I don't just newly allocate it and hold on to the pointer. I take their rando pointer and stuff a new object into it. I think. Where does that exist? What the factory? Ah, thank you. Someone's found it. Greco, of course. It's factory S instance. Right, okay. It'll work this time. Nope. Oh, if you think I see a different chat, it's because I dual stream on Twitch and YouTube, and then I have a program running on my second monitor which has all the chats combined, so I see everyone's messages they come in, and I kind of just sort of reply to both. My debugger just crashed. Like, it's having a really bad time with that. It literally just crashed. I hope it's remembered all my breakpoints. Oh, interesting. Is Twitch not linked on the YouTube page? Fine. It's my name. It should be easy to find. I pin a comment. It should be the pinned comment on the YouTube chat where the Twitch account is. Like, I always start off YouTube chat with a pinned comment to Twitch. Okay, let's try. Okay, that's fine. Where are we now? Impose. What is? Okay, fine. I am very confused. Why is it jumping over to random bits of code? Where am I now? Why am I in... Where the heck am I? Why am I in this thread? Oh, is it spun up a load of threads? That's really annoying. Once I just continue. Oh, it works under the debugger. Wasn't expecting that. So why is it not working here? Hey? Oh, fine. I don't know what happened there. So we don't get any logging. But, you know, right, they have an example of logging. I'm just going to copy, last bit of copying their code. They have in their update method, they grab the position and velocity of the object. So what I'm going to do is do that. So what is this sphere ID type? It's a body ID. So let's do GPH body ID sphere. Okay, and then we'll go down to sphere ID and do impl sphere equals that, and then impl sphere equals that. Okay, now in the update, after we've done the update, we should be able to do const auto position equals impl physics system dot get body interface dot get center of mass position. Impl sphere, okay. And then do log info position dot. Oh, interesting. Getters. How bohemian. Okay. Okay, I think that's physicsing, because it starts off here and then it hits the floor, which is presumably, if its radius is a half, then it will be roughly a half above the thing. So I think we're physicsing. Oh, excuse me. Right, where's me? Slightly anticlimactic. Well, I don't know. You tell me. Is that anticlimactic? We wrote a lot of code and we saw some numbers. There's nothing visual, but like, I think hopefully we can kind of see the amount of work that's going to be involved in here. This is definitely going to be a several stream kind of effort. Tom901 subscribe to Twitch. Thank you very much. Much appreciated. So yeah, I think I'm pleased with that. I think that's pretty cool. I think, you know, for 3 hours work, we integrated a AAA physics engine into our game. I don't think it's too bad. It's not particularly compelling to look at, but then sometimes that's just the case. Excuse me. So yeah, I think what we'll do next time. Anonymous, a nice name, member on YouTube, much appreciated, thank you very much. So what we'll do is next stream, which will be Wednesday, all being well, is we will pull out all of that stuff that we built in the physics engine, and we'll pull all that out in separate primitives, so it's very easy for us to basically say, I want a sphere, I want a cylinder, I want a capsule. You know, we'll start building out with the primitives and we'll just start writing through them. All that horror of like the Jolt API, and not that it's a bad API, but there's a lot of typing. We're gonna hide all that away behind our own implementation. Yeah, it'll be a couple of streams, I think. Yeah, we need a rigid body class, we need a shape class. That's probably it, actually, really. And then we need a debug layer class or debug draw class, because I think we want to be able to visualize it. And then, yeah, we need box, capsule, cylinder. That's probably enough to get us going. I'm hoping Jolt has like here's a 3D mesh, please wrap it in a collision detector for us, but we'll see how we get on. Otherwise we'll walk through the triangles ourselves and build it. Okay, that's pretty much all I've got. Thank you very much for everyone who came along. If you were new, thank you. If you are not new, thank you. And we'll see you all on Wednesday. Have a good one.